Okay, this is question 3. It says, given that z plus 2i is a root, so straight away you know that 3 minus 2i is also a root. So if you've got two roots, that means that if you multiply them together, you'll get a factor. So you've got z minus 3 minus 2i is one root, and z minus 3 plus 2i is another root, and there are going to be more roots to follow, and this would all multiply to give you that. So if I just multiply these together first to see what we've got to so far, we'll get z squared from that times that, then minus 3z, then 3z, then plus 2iz, and then minus 3 times the z, so it's minus 3z again, and then plus 9, and then minus 6i, minus 2iz, plus 6i, and plus 4, minus 2i times minus 2 is minus 4, I squared is minus 1, so plus 4 at the end. Okay, let's simplify that out. So we've got z squared. In terms of z's, we've got a minus 3z, minus another 3z, so that's going to give us minus 6z, so that one and that one give me minus 6z. And then we've got a 2iz and a minus 2iz, cancel out. We've got a plus 6i and a minus 6i, cancel out. And 9 add 4 is 13. So z squared minus 6z plus 13 is that multiplied out. So that's also going to be some form of a factor. Okay, now if we think about what's going to go in there, to get z to the 4 we're going to need a z squared term. So if we think about this times another quadratic, we'll call it z squared, because I know there's no coefficient of z to the 4, so z squared is going to have a 1 coefficient, plus something in the middle, I'll call it alpha z, plus beta. So I'm just going to sort of say that these are two random things, and that must equal all of that when we multiply it out. It must equal z to the 4 plus a z cubed plus 6z squared plus bz plus 65. Okay, now straight away I can see that, change colour, 13 times the b must equal the 65. So I can straight away see that beta, it's 13, beta must equal 65, therefore beta is 5. And change colour again. And the next one we're going to get is, should we go for the z's? Yeah, do the z squareds. So if you do z squareds, we've got z squared times beta. So we've got beta z squared. Whoa, sorry. I'll tidy that up. Beta z squared from z squared times that beta minus 6 alpha z squared. That's going to give me a z squared term. And then plus 13z squared. So we're going to get all of those things there, and that must equal the z squared on this side, which is just 6z squared. So let's cancel out the z squareds. So I see beta, which I already know is 5, minus 6 alpha plus 13 equals 6. So minus 6 alpha equals 6 take away 18 minus 12, so alpha equals 2. So I've got my alpha and my beta, so now I know that this thing here is going to be z squared plus 2z plus 5, because alpha was 2 and beta was 5, and then if I move down a bit, then if we factorise this, which I won't factorise, so that's going to be a complex answer. So we're going to get to this stage. To get our other two roots, you're going to get, I would complete the square on this. Remember, we're trying to make it equal 0 to be a root. So if this equals 0, z plus 1 squared minus 1 plus 5 is 0. Minus 1 plus 5 is 4, so it's minus 4 on this side. So z plus 1 equals square root of minus 4, which is 2i, plus or minus 2i, and then take away 1. So z is minus 1 minus 2i and minus 1 plus 2i. So they're your other two roots. So it said, show the roots of the equation on a single diagram diagram. So you've got this root here and this root here. So z equals this, and z equals this, and those two. So on an argand diagram, minus 1 is left, plus 2i is up to 2, and minus 1 minus 2i is left and down, and then 3 plus 2i is all the way along but up the same amount, and there we go. So you've got this one here, this one here, this one over here, and this one over here. It would make a rectangle because they're the same height, and that's it. Question 3 done.